أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم.
Moderation Analysis. Introduction. Moderation describes a situation in which the relationship between two constructs is not constant, but is actually dependent on the values of a third variable that we refer to as a moderating variable. Now, this moderating variable changes the strength or even the direction of relationship between the two constructs in a model. That is, it may strengthen, it may weaken the relationship between two constructs in a study. Now, for example, research has shown the relationship between culture and organizational performance differs as a function of role ambiguity. That is, if there is high role ambiguity, the relationship between collaborative culture, that is the example variable for this particular lecture, and organizational performance, it actually weakens. However, at low role ambiguity, this particular relationship is further strengthened. Moderating relationships are hypothesized a priori by the researcher. The testing of moderating relationship depends on whether the researcher hypothesizes whether one specific model relationship or whether all model relationships depend on the value of the moderator. Now, the test that we use is dependent on whether a single relationship is being moderated or whether all the relationships in the model are moderated. Modeling moderating effects. Now, this figure illustrates two-stage approach that we are going to use for moderation analysis. This is stage 1 and this is stage 2 with the moderating effect. Now, the main effect model in stage 1, that is the impact of moderator on the dependent variable and the impact of independent exogenous variable on the dependent variable. Now, this is the relationship, that is P1 is being moderated by this M moderating variable. Now, how do we model this? We model this in stage 2. So your modeling of moderating effects is actually divided in stage 1 and stage 2 when you are using a two-stage approach that is recommended for modeling moderating effects. Now, the main effect model in stage 1, this is the main effect model where we only have the IV exogenous variable, the moderating variable, and that is impacting Y2. Now, both of them are exogenous variables for this endogenous variable. And we've got variable scores, or now we run this to obtain the latent variable scores for Y1, Y2, and M. Now we run this model and we get our latent variable scores for these constructs. The latent variable scores of Y1 and M are then multiplied like this, and we get a single item that is used to measure the moderating or interaction effect or interaction term. The latent variables Y1, Y2, and M are each measured with a single item of the latent variable scores from stage 1. Now in stage 2, all these are measured using a single item. And what is this single item? This is the latent variable score that we got from stage 1. Now it is important to note that the limitations identified for single item scale do not apply here because we got these latent variable scores from these multiple items from stage 1. Model evaluation. For the interaction term, there is no requirement to assess its measurement model. The interaction term will not be assessed for the quality criteria that we normally do for our other latent variables. Now, what we normally do or what we should do is we need to evaluate our measurement model, that is reliability and validity of the constructs without the moderating effect. Before adding the moderating effect to the model, you should have another model whereby you assess the reliability and validity of all your constructs. Now, this is actually an auxiliary measurement that incorporates the interrelationship between the moderator and the exogenous construct in the path model. This characteristic, however, renders any measurement model assessment of the interaction term meaningless. In addition, standard measurement model evaluation standards would not apply since the interaction term is measured using single item. Therefore, the interaction term does not necessarily have to be assessed in the measurement model evaluation step. So whenever you are performing your moderation analysis, you do not incorporate the moderating effect in your measurement model analysis. You only include it after you have done your measurement model analysis. Now finally, it's always important to consider the standard criteria for structural model assessment. In the context of moderation, particular attention should be paid to F-square effect size of the interaction effect. Now, how do we calculate F-square effect size? We are going to look into the formula and the whole process as well. This criterion enables an assessment of the change in R-square value when an exogenous construct is omitted from the model. With regard to the interaction effect, the F-square effect size indicates how much the moderation contributes to the explanation of endogenous construct. So F-square effect size will tell you it's the contribution of the moderation in explanation of the endogenous construct. And how it is calculated? The simple formula is like this. R square included, R square excluded, 1 minus R square included. R square included means with the inclusion of moderating effect. R square excluded means with the exclusion of moderating effect. Where R square included and R square excluded are the R square values of the endogenous construct when the interaction term of the moderator model is included or excluded from the PLS path model. In this way, one can assess the relevance of moderating effect, whether or not the moderating effect is contributing towards the endogenous construct or not. General guidelines for assessing F-square suggest values of 0.02, 0.15 and 0.35 for small, medium and large effect sizes, and these values are suggested by Cohen in 1988. However, Aguinis and others have shown that the average effect size in tests of moderation is only 0.009. Now against this background, Kenny in 2018 proposes that 0.005, 0.01 and 0.025 respectively constitute more realistic standards for small, medium and large effect sizes, but also points out that even these values are very optimistic, that you may not get a very large effect size. Moderator variable is introduced through the interaction term in the PLS path model, but the fundamental question remains: how should the interaction term be operationalized? Research has proposed three primary methods. Simulation studies have shown that Chin, Marcolin and Newstead in 2013 two-stage approach excels in terms of parameter recovery and statistical power. Now in addition, this approach offers much flexibility as it is the only approach that is applicable when the exogenous construct Y1 or the moderator M is specified formatively. Now we therefore recommend using two-stage approach in most situations of creating the interaction term. So two-stage approach is preferred. Now you need two-stage approach when you want to know the significance of moderating effect. So this is the approach that we are going to use. I've used these two references for the preparation of this particular lecture. I hope this session would have helped you understand the concept of moderation. Thank you very much.